All right, hello everybody. Here's your homework for 9.5. I'm going to go through this, see how we do here. So it says write each decimal as a fraction or fractional decimal. Sine D, sine E, cosine E, cosine D. Okay. So if I'm looking for the sine and cosine, so again, just a little refresher. Your sine function of whatever angle you have is going to be your opposite over your hypotenuse, and the cosine is going to be of an angle is going to be your adjacent over your hypotenuse. All right, so let's put those two figures in our mind. Right? Make this look a little nicer in a second. So if you have the sine of, look at an angle E. So the sine of E is going to be opposite. It's going to be 12 over the hypotenuse, which would be 37. The cosine of E will be the adjacent, 35, over the hypotenuse, 37. All right, and sine of D is equal to opposite, which is 35, over the hypotenuse, and the cosine of D is equal to the adjacent, which is 12, over the hypotenuse. All right, keeping going down. So now we have cosine of, so same here. So sine of E, again, opposite, over the hypotenuse. Cosine of E, adjacent, over the hypotenuse. And last one here, sine of E, sine of D, opposite, over the hypotenuse. Always over the hypotenuse. Sine and cosine are always going over the hypotenuse. All right, and then the cosine of D is the adjacent over the hypotenuse. All right, and we're just going to follow this all the way down. We got one more to do. All right, for number 6, I'm just going to put my number 6 here. Give me a little more room, okay? So sine of E, opposite, over hypotenuse. Cosine of E, adjacent, over hypotenuse. Sine of D, opposite, over the hypotenuse. Cosine of D, adjacent, over hypotenuse. All right, and those are all your fractions of decimals, okay? So once you know that angle, you could plug in the angle, sine of that angle into your calculator, and it should equal the same thing as 15 over 17. And we'll learn soon how to find that angle. All right, write the expressions in terms of cosine. Okay, so we saw that sine of A is equal to cosine of 90 minus A. So sine of 81 is the cosine of 90 minus 81, or 9. And again, this one's going to be 90 minus 64, which is going to be 26. So this will be the cosine of 26. Okay, so this one, cosine, so cosine, same thing, cosine of an angle, A, is equal to the sine of 90 minus its angle. So all we really need here is 90 minus 42, which is 48. So cosine of 42 is the same as sine of 48. So if you take a moment and you just plug in your calculator cosine of 42 and hit enter, and you do sine of 48 and you hit enter, you'll get the same value of about 0.74. Right? They're going to have the same exact decimal there. All right, and then again, this is just going to be 90 minus 18, which is equal to 72. So this is just going to be the sine of 72 degrees. All right, these are all degrees. Okay. Find the value of each variable using sine and cosine. Okay, so I'm looking for P. Okay, so here's my angle. That's opposite, and that's my hypotenuse. So I can say the sine of 64 degrees is equal to the opposite over hypotenuse. Okay, and then very similar to when we did with this with tangent, we multiply both sides by 34, and P is going to equal 34 times the sine of 64 degrees. All right, 34 times the sine of 64, we got about 30.56 rounding to the hundredths. Okay, then we need Q. All right, so for Q I have, this is the adjacent, and there's my hypotenuse. So I'm going to use the cosine of 64 degrees is equal to the adjacent over the hypotenuse. So, same process, multiply by 34 on both sides, and I get 34 cosine of 64 degrees is equal to Q, 34 times cosine of 64 degrees, and I get about, Q is approximately equal to 14.9. Yeah, we'll do number 18 over here. Okay, so my angle S, or my angle 43, opposite 43 is S, and the hypotenuse is 26. So, the sine of 43 degrees is equal to the opposite over 26. Multiply both sides by 26. So S is equal to 26 times the sine of 43 degrees. And you calculate 26 sine of 43. You don't have to put the multiplication sign there. It's already implied. And this is equal to 17.73. And using the same thing, this time we use the adjacent angle. So when I'm using the adjacent angle, I'm going to use cosine. So cosine of 43 degrees is equal to the adjacent, which is r, over the hypotenuse, which is 26. Again, multiply both sides by 26. So r is equal to 26 times the cosine 43 degrees. Pop that right into your calculator, and you get approximately to about 19.02 rounding to the hundredths. Alright, so that's 2 through 18. And let's tackle number 20 here. I'm going to screenshot number 20 and I'll do it on the bottom here. Okay, so number 20, the directions just read something, not sure, but find the value of each variable. Okay, so same thing. So, same thing as we just did. Okay, here's your angle. Remember, this is my hypotenuse, right, because it's opposite to 90, so I'm missing the hypotenuse. I can find the hypotenuse. I have the opposite side here. So since I have the opposite, I can say the sine of 50 degrees is equal to opposite over hypotenuse. So I'm going to do a little math here that we showed in the other piece. Again, all that's going to happen here is this numerator and this denominator are going to switch. So pretty much I could write this as n equals 8 over sine of 50, and a little algebra here on the side. If you have a equals b over c, I could clear my fraction, multiply both sides by c. This will give me ca equals b. Then divide both sides by a here, and c equals b over a. And all I'm trying to show you here is that if my original piece here, comparing these two, my numerator, my denominator, now turns into my new numerator and my new denominator. So they just switch. You could go through all the algebra here, and I would do it until you feel comfortable. But that's really all that's happening. And this is just going to be 8 divided by sine of 50, and this is approximately going to equal 10.44, rounding to the hundredths. Alright, so this is 10.44 rounding, and I can use this 10.44, or I'm going to say for this next angle I could do whatever I want, but I have the angle here, I have the opposite, and I'm missing the adjacent, so why not go back to tangent? So the tangent 50 degrees is the opposite over the adjacent, which is m. If you want to just use sine and cosine, well then you could do cosine of 50 degrees is equal to the adjacent over, now you found your hypotenuse, which is 10.44, and you should get pretty much the same answer. This way might be a little easier than the other way, but same answer. So m is equal to, that's going to cross out, 10.44 times the cosine of 50 degrees. And there's going to be a little bit of error there because I rounded this 10.44, and I'm using that rounding for the cosine of 50. So this is equal to about 6.71. Okay, keep it going. Number 24, and next one. Describe what you must know about the triangle to use the sine cosine ratio. To use the sine, again, this is the opposite over the hypotenuse. You need to know two of the three informations in order to solve. Alright, so if you have the sine, if you have the angle on the opposite side, you can solve for the hypotenuse, but you need two of the three, just like your cosine is your adjacent over your hypotenuse. Again, you must have two of the three pieces of information here. Alright, number 26. 26 is a good one. Which of the following is not equal to the ratio of the length of the adjacent angle P to the length of the hypotenuse? Okay, so I'm going to read this one more time carefully. Which of the following is not equal to the ratio? So the ratio of the length of the adjacent to P, so that's PQ, and to the length of the hypotenuse, so PR. So anything that doesn't have that ratio should not work. So the first one is sine of R. Okay, so sine of R is equal to the opposite, which is PQ, over the hypotenuse, PR. So that works. Cosine of P is the adjacent, which is PQ, over the hypotenuse, PR. So that's the ratio I'm trying to get. So check and check. And then there's a ratio here that says QR over RP. Well, that doesn't work because I need PQ over PR, which is this right here. So that's the one that doesn't work. Okay, so find the length of the slide. So I'm missing this is opposite the 90, so I'm missing the hypotenuse. I have an angle here. And let's see, so I have an angle, I have the opposite leg, and I'm missing the hypotenuse. So I have the opposite, so I'm going to use sine of the angle, opposite over hypotenuse. So the sine of 53 is equal to 12 over h. Alright, again, I'm going to use a little trick there, a little strategy there before. These two are just going to switch. So h equals 12 over sine of 53. And then put them right into my calculator. 12 divided by sine of 53. And I get about 15.03 rounding to the nearest hundredths. Alright, so we got 27 out of the way. We're going to do 28, 30, and 35. 28, kind of same concept here. I have an angle. I'm missing the height. This is the adjacent. So if this is the adjacent, then I'm going to do cosine of that angle. Just cosine of 45 is equal to the adjacent over 438. This one, the math is a little easier. Multiply both sides by 438, and you get x is equal to 438 times the cosine of 45 degrees. 438 times the cosine of 45, and it's about 309.71. Alright, 28, 30, and 35, that was, okay, 30 and 35. So 30, okay, 30, I like 30 because you kind of have to make your own picture here. So you're flying a kite using a 20-foot long string. The angle of elevation, so there's me, okay, there's my kite. So this is the angle of elevation, right? So the angle of elevation is 67 degrees. The kite, there's my string, that's 20 feet. So check, check. Your hands are 5 feet above the ground. So I got 5 feet there. Right, so there's the ground. So this part here is 5 feet. How far above the ground is the kite? So I need my angle of elevation is my eyes. I'm holding it. So I need this piece here, which I don't know, and then whatever that is, plus another 5 feet, because that's where I'm holding it from. So when I think about this, I have the opposite and my hypotenuse. So I'm going to use my cosine here. I'm sorry, my sine. So the sine of 67 is equal to the opposite, which is unknown, over what I do know, my hypotenuse. All right, so simple multiplying by 20 on both sides crosses that out. So the height here, x, that I don't know, is going to be 20 times the sine of 67, which is about 18.41, and then plus another 5, which gives me height off the ground of 23.41. And part B is critical thinking, so as the angle of elevation changes, so this is my piece here, as the angle of elevation changes, sorry, not you, so as this changes, and it goes up, it says, does your kite change at a constant rate? Well, if the angle of elevation is increasing at a constant rate, then the straight line here will always be increasing at a constant rate too. So as long as the angle of elevation is increasing at a constant rate, then yes, then this is also increasing at a constant rate. Alright, and number 35, let's see, we got a picture here. Alright, the sonar system of submarine detects icebergs ahead. Okay, there's my icebergs. How many yards must the submarine descend? Okay, so I need this height here. So I need to know the opposite. And I have the adjacent here. Okay, so that's so opposite and adjacent. So part A, I'm going to use opposite and adjacent. I'm going to use tangent for this one. This tangent of angle is equal to, let me erase this. So tangent of angle is equal to the opposite over adjacent. That's what I have here. I don't have the Yep, so I need to descend here. So I got the tangent of 34 is equal to the opposite, which I don't know. I'm just going to call that x, not o, just to not make that look like a 0. We'll call this x. X over 4,000. So I'm just going to multiply both sides by 4,000 here to get that. So x is equal to 4,000 tan 34. So 4,000 tan 34. I'm looking at about 2698.03, rounding to the hundredths. So that's how many yards it must decrease. And then part B says the sonar system that detects a sunken ship 1,500 yards ahead with an angle of elevation 19 degrees. How many yards must the submarine raise to pass over? So again, now this one I'm looking for this. So my picture here, I'll do this one here. So here's my triangle. This is 19 degrees. This is 1,500. I need this piece here. I'll call this y. So opposite over adjacent again. So the tangent of 19 is equal to the opposite over the adjacent. So this is just going to be y is equal to 1,500 times the tangent of 19. So the distance it must raise to not hit that boat is about 516.49 yards. All right, and I think that was the end of the problems there. All right, good luck with your homework. Hopefully that helped.